All right, so if you're a developer, you've probably been using AI coding assistants. And you know that feeling, right? That incredible rush of building things faster than you ever thought possible. But here's the big question. Are you building things that actually last? Today, we're going to dig into how to really master building great software with AI, and, more importantly, how to sidestep some really common, really dangerous traps.
Yeah, there's a name for this, and it's called vibe coding. And it's exactly what it sounds like. You have this vibe for what you want to build. You describe it to the AI and poof, the code just appears. It's magical. It's all about that speed, that instant gratification of seeing your idea become real right now. And honestly, it feels like a superpower, doesn't it? But every superpower has its kryptonite. So what's the catch? What's the hidden costs we're paying for all this incredible speed? And here it is. This is the core paradox of the whole thing. The AI's strength? Blazing speed. I mean, it writes code in seconds. But its weakness? Man, it is a big one. It's completely blind to everything that makes software last. We're talking about architecture, security, maintainability, the important stuff. The AI, it's building for right now, not for a year from now.
So the trick, right, is how do you get all that speed without inheriting the AI's blindness? Well, your role, your whole job, it has to change. You've got to move from just being a coder, someone who just writes prompts, to being a true system architect.
And we're going to walk through exactly what that journey looks like. We'll cover the key phases, the blueprint, the plan, the build, and the launch. And for each one, we're going to pinpoint a really specific AI trap and show you the exact remedy to get around it. Okay, let's dive into phase one, the blueprint. And listen up, because getting this part right is how you're going to avoid what is, without a doubt, the single most dangerous trap of vibe coding, something called accidental architecture. So here's the trap. If you just jump in, no plan, and tell the AI, hey, build me this thing, it will start making huge architectural decisions for you. But here's the sneaky part. It won't tell you it's doing it. So you end up with this accidental architecture, this invisible foundation that feels fine at first, but it's incredibly brittle. And the second you need to change something, boom, the whole thing just shatters.
So how do we fix this? The remedy is actually a really simple but super powerful mantra to remember. IIA Before AI. That's infrastructure and architecture before AI. You have to decide on the structure first, before you let the AI touch a single line of code. Think of it this way. You're the architect with the blueprint. The AI is just the construction crew.
Okay, so how do you actually create that blueprint? Well, you start by asking yourself 5 absolutely critical system questions. Let's go through them. Question 1. What is likely to change later? You have to think ahead. If you know you might add new customer types or change your pricing, well, you know right away those things cannot be hard-coded by the AI. Next up, question 2. Should this thing exist just once, or does it need to be everywhere? This question is your best defense against messy, duplicated code. It forces you to think about building shared, reusable components and having one single source of truth for your logic. All right, question 3, and this one is so important. What is the source of truth? Where does the definitive data live? Is it in a config file, the database? Is it coming from the user? You and only you have to make that call. You can't let the AI guess. Question 4 is a big one. What breaks if I change this? This forces you to think about all the dependencies, all the knock-on effects, right, from the start. It's about seeing the ripples before you throw the stone, It prevents a small change from turning into a total disaster down the road. And finally, question 5. How would I test this? And this is a great gut check. If you're thinking about a feature and it just feels awkward or super difficult to test, that's not a testing problem. That's a design problem. It's a massive red flag telling you your architecture is probably off. Okay, so now that we've got our blueprints, we're ready to move on to phase 2, planning. This is where we take control and make sure the AI doesn't just hand us a big old tangled mess of spaghetti code. And the trap here is just being too vague. If you give the AI a prompt like, hey, build an expense app, it's just going to go wild. It'll happily start making assumptions, adding all sorts of features you never even asked for, and before you know it, you've got this impossible to maintain spaghetti code base. The remedy is all about setting up the right relationship. You've got to think of the AI as your new junior developer. Yeah, it's incredibly fast, but it's also really naive. You are the lead developer. You are the product manager. You define the scope. You are in charge, period. So here's your action plan to make that happen. First, before it writes any code, make the AI explain its assumptions back to you. Ask it questions. Correct it. Second, make it give you a step-by-step plan. And third, and this is super important, keep your own notes. Don't rely on the AI's memory because, trust me, it's not reliable. All right, solid plan in hand, we're ready for phase 3, the build phase. But we gotta be really careful here because this is where the AI's natural optimism can turn into a huge, huge security risk. See, the trap is that the AI lives exclusively on what we call the happy path. It writes code assuming a perfect world. A world where users never make typos, networks are always up, and nobody has bad intentions. It almost never thinks about edge cases, errors, or security unless you literally force it to. And if you think I'm exaggerating, check this out. One study from Stanford found that 40% of the code that GitHub Copilot suggested had security vulnerabilities. Let that sink in. 40%. It's a huge reminder that these AIs are trained on public code and, well, a lot of public code is just not secure. So the remedy is what I'd call incremental control. It means you have to review every single line of code it generates. No exceptions. You have to tell it, hey, do not hard code these values. You have to specifically prompt it for the unhappy path. What if the data is wrong? What if it's missing? And finally, use Git. Use it religiously. Commit your work often, because I promise you the AI will break things, and you're gonna need an escape hatch. Okay, so your feature is built, you've reviewed it, it's committed, you're feeling good, you're ready for phase 4, the launch. But hold on, not so fast. We have to tackle that classic developer trap, the it works on my machine illusion. And AI makes this trap so much easier to fall into. And this gets to the heart of the great illusion of vibe coding. You feel like you're moving at light speed, but that's because you're measuring the wrong thing. You're measuring how fast you can write code. That's not what matters. The only metric that counts is the speed of shipping stable, production-ready code. Code that actually works for your users, not just on your laptop. The remedy here is simple. You have to prove it works. First, try test-driven development. Get the AI to write the tests before it writes the code for the feature. Second, build little internal tools for yourself to check and verify complex stuff. And third, and this is for your own good, every once in a while, rebuild an AI feature completely by yourself from scratch. It keeps your skills sharp. So we've gone all the way from the blueprint to the launch. What does this all add up to? What is your new job, your new role in this age of AI? I think it really boils down to this. Every developer right now is standing at a fork in the road. Down one path, you can be a vibe coder. You focus on how fast you can write a prompt, you live on the happy path, and yeah, you'll ship features really quickly. Or you can take the other path. You can become a system architect. You focus on system design, you plan for things to fail, you plan for change, and you ship stable, lasting systems. One person builds features, the other builds real, enduring value. And all of this leaves us with one last big question to think about. As the AI just gets better and better at writing the actual code, what's left? What is the most valuable human skill? And the answer, really, is everything we just talked about. It's foresight, it's judgment, it's architecture. That is the future of your role.